Hi folks, we're going to take a look at number 6 here. We're going to see yet another way of solving an exponential equation. Okay, so let's take a look at what we have here. So 6 to the x minus 6 to the negative x equals 1. So remember what we talked about before is can you write all the exponential terms so that they've got the same power? Okay, so here I hope you think, hey, wait a minute, 6 to the negative x can be rewritten a different way. Okay, the effect of a negative exponent is to just create the reciprocal. So 6 to the negative x is the same as 1 over 6 to the x. And what's great here is that, hey, 6 to the x, and again, I've got the exact same power. Okay, so at this point here, you realize, hey, wait a minute. I've got this expression in the numerator, but I also have that expression in the denominator. I have a variable expression in the denominator. And you realize, hey, this looks a lot like a rational equation. Okay, so in the same way that we used our methods for solving polynomials to help us with those previous questions, here we'll use our methods for solving rational equations to help us out. And of course, our main method for solving rational equations is to just get rid of the denominator altogether. And we do that by multiplying both sides of the equation by the lowest common denominator, which in this case here, there's only one denominator, so 6 to the x. Okay, so let's do that here. We have 6 to the x times 6 to the x. Now, since I want to keep the 6 to the x, I'm going to write that as 6 to the x squared instead of 6 to the 2x minus, well, here the 6 to the x reduces, so I'm just left with 1. Then here, 6 to the x. And then I realize, hey, wait a minute, this looks familiar. This looks a lot like what we saw earlier, a quadratic polynomial. Okay, and of course the way to solve that is to bring everything to one side of the equation. So 6 to the x squared minus 6 to the x minus 1 equals 0. And again, if you feel that it helps to bring in an intermediary variable, you can do that. So this becomes z squared minus z minus 1 equals 0. Now one difference here is that this is not factorable. So no need to worry, we still have the quadratic formula. So z then can be equal to negative b, so that's 1 plus or minus square root of b squared, so 1 minus 4 times 1 times negative 1 all over 2. So z is equal to 1 plus or minus square root of 5 over 2. Okay, but of course it's not z we're interested in, it's x. So now I'll replace z by 6 to the x, and I'll actually write it as its two separate solutions here. So 6 to the x is either 1 plus root 5 over 2, or 6 to the x is 1 minus root 5 over 2. Okay, now first of all, let me actually deal with the second one, because I realize here root 5 is bigger than 1. So 1 minus this number is going to be negative. 6 to the x can never be negative, so there's no solution that comes from that portion. So the only solution we have is this one here. I'm going to take log base 6 of both sides. So log base 6 of 1 plus root 5 over 2. Okay, and of course, if I wanted an approximation, I would use the change of base formula to turn this into log base 10. Okay, so just to recap, I use a similar trick as I did before, is use my exponent rules to write all the powers to be the same. So in this case here, I use the fact that a negative exponent just gives me the reciprocal. And then from that point there, I recognize this as being similar to a rational equation. So I use the same techniques, which is to multiply both sides by the lowest common denominator. Okay, and that's it for this one here.